Hello and welcome to Unit 3 on Dynamics. In Dynamics here we're going to be introducing forces. We're going to be introducing free body diagrams. Free body diagrams is what our first example is going to be based on. And really all a free body diagram is a sketch or a representation of some object that we are dealing with in a problem. And listing the forces that apply to it. So in example 1 of our workbook, we have a question asking us about this person. The sketch looks somewhat like this in the book. And what it is, it's a person who it says is 600 newtons, which really right now is a little bit irrelevant. And he's holding a textbook. That's what this blue box is. In his arms, and it says that it's a, what is that, 20 Newton textbook? And also he's sitting in a chair that's 40 newtons. A little bit irrelevant for the question, but it's nice to introduce weights in newtons here. So, jumping into this example, the first part of this example is A and B, is asking us to sketch a free body diagram of the book. So I'm going to switch back to the blue color that I have for the book here. And, oops, let me turn on this rectangle. There we go. Focus something like that. We can even fill it in if we want. Okay. And what do we want to do on this? So a free body diagram. Essentially what we're going to be doing is we're just listing off all of the forces that are going to apply to this book. Now, an object will move if forces are unbalanced. But an object that is at rest is said to have equal or balanced forces acting upon it. So there are two forces at play here. The first force at play is, of course, gravity. That's one that I think most people would call out right off the bat. So we're going to draw ourselves an arrow in the direction that gravity is acting, right? In fact, the direction that gravity is acting here is the same direction the acceleration due to gravity is acting. And we're going to find out really soon that that's because the formula for force is equal to mass times acceleration. So if the direction of acceleration is down, so is that value for the force. Okay, anyways, I'm going to label this little diagram here with FG. FG is going to represent force, then subscript G for gravity. Alright, this textbook though isn't moving, which means there's some sort of force balancing out gravity. That other force is opposite direction because this thing's not moving. And we can call this the force of the person, we can call it the force of lift. Really whatever we want to call this thing. I'm going to dictate this thing, or name this thing FP, I think. Force of person. Alright. This object only really has those two forces acting on it. But when we get to B, B is the force of the person. Not the force of the person, but the free body diagram of the person. Now, I could draw this person out here, but the laziness in me is just going to represent this person as a box. Maybe I'll make this person a red box, so it's not completely difficult to see where we're coming from. Now, I guess I can fill this box in if we want. You don't always have to fill your objects in. You never have to fill them in if you don't want to. Okay. Let's choose our black color so we can draw some lines here and list off the forces that are acting on this person. Well, I can think of a number of forces that are acting on this person. Force number 1, I'm going to just start off with gravity. So I'm going to draw one arrow downward. There we go. And we'll label this FG. Alright. Anything else that's pushing down? Well, in a way, yes. This book, just as the person is pushing up on the book is pushing down on the hands of the person. So, in the downward direction, I'm going to say that downwards here, we have force of book. Okay. I think those are the only two forces that I see pushing down on the person. But let's get to the forces upward. Okay. In the upward direction, I can see force of chair on the person, because just as the person pushes down on the chair with their weight, the chair is pushing back up. So we can say, whoop, in the upward direction, we have force of chair. I'm going to put CHAIR, just because FC is sort of saved for centripetal force, which we won't be getting to for a while, but it will be eventually coming in. And it just looks weird if we have an FC on here. Okay, what else do we have? Well, right here, it's not really clear, but it does kind of look like this person's feet are on the floor. So only some of his weight or most of his weight is on the chair. I'd say a small amount is probably on the floor. So we can say that we have a force of the floor as well. Force of floor. I'm also writing out floor because FF is typically reserved for force of friction. And it does look, again, a little bit weird if we have an FF on there. Okay, let me check my notes and see if we have anything. I don't particularly see anything extra, and I think those are really the only 4 forces acting on this person. Alright, that concludes example number 1. Stay tuned.